Hi guys, welcome to the webcast. Uh, Today we're going to be talking about stage 2 tips and tricks, and my name is Rahul. I'm a Udacity coach,
I'm Anthony.
also Udacity coach. And yeah, so today we want to address some issues that you guys might have been having with the Code Your Own quiz project. And by the end of this webcast, hopefully you'll have an idea of not only to how to approach this particular programming problem posed by stage 2, but also programming problems in general, just being able to identify the problem and break it down.
Yeah, definitely. So before this webcast, we looked into some of the common reasons why students do not meet specifications on the Stage 2 project. And the top reasons were not commenting at the beginning of functions, not using functions appropriately to automate repeated tasks, or having functions that are longer than 18 lines of code.
And there are some smaller issues like prompting the users to try again and printing the quiz after you've replaced the blank. But overall, almost all these problems that have one commonality, and that is that they all have to do with properly defining functions. And because of that, we're going to be focusing almost entirely today on how to read a problem, break down the problem in such a way that it makes it easy to develop functions when the time comes for it.
So one of the first places that is one of the great way to start off approaching this type of problem is you've got this like much larger problem, right? So the Stage 2 project, you have this huge problem that is create a fill in the blanks quiz. Now that's going to be involving a lot of different tasks, a lot of different steps, and really one of the first things you want to do is not think about it at that large scale problem. You want to think about it as these individual tasks.
And for that, we're not going to kind of break down the whole problem for you because that is
that's your job.
That's your job. That's why you're taking this course. But we're going to try to what we're going to try to do is provide an analogous problem and kind of show you how we go step by step to break down this problem, and most importantly, how we break down this problem can inform the way that we code a solution to this problem. So today, I'm going to share this following problem with you. It's a very simple one, but the idea is to just get you thinking about how to abstract away the big parts of what you're being asked. So let's open up Sublime over here.
Got a screen share.
Yeah, I'm just pasting it here first. 1 second. Promise that I'm actually doing something. And let's just share Sublime. Okay. Is that showing up? There you go. Okay, so the problem that we're going to be working on today is show user three different people drinking Coke. I think that's a sufficiently ambiguous problem, and some of you might be approaching the Stage 2 project as a sufficiently ambiguous problem as well. So for that reason, let's just break down what it is we're trying to talk about. So what does show mean here? Well, because there's sometimes like no one we can ask to kind of clarify the certain parts of a problem, we sometimes have to make a reasonable assumption about what's meant and try to move forward like that. So let's assume that in this case, show means print. It may or may not mean it, but for our purposes and moving forward, we're going to say that show means print. Now, the second part of this problem is show a user 3 different people drinking Coke. What does that mean? Well, I think that here we can also make another assumption that show means printing. So we might want to print 3 different people. Because we're not given the people like we're told to print out, we can assume that we can just make them up. So we can also assume that drinking Coke could also be like just a word, a string, some sentence that we print out. So here, we've kind of broken down the problem logically, and with that, we've kind of like talked out what it is we want to say. And this is kind of what we wanted to, what we just went over. We said that we want to have 3 people we want to print, ready to be printed. And we want to take the first person, print the first person drinking Coke, take in the second person, print the second person drinking Coke, and take in the third person and print that person drinking Coke as well. Seems kind of silly, but what we've done here is just really kind of broken down this ambiguous question and given ourselves in comments direction to actually go forward and code something.
Yeah, and this is one of goes back to one of the reasons why a lot of students don't pass stage 2 is not commenting at the start of functions.
Right.
And that's a huge reason why that requirement exists. We want you to start your functions with a comment explaining what the inputs, outputs, and tasks of your function are. Yeah. It's a great way, actually, not only to verify that that's what your function is doing when you have finished writing it, but to actually do it before you even write it and start thinking about those questions. What are my function's inputs? What are its outputs? And what tasks should it actually complete?
Right. And notice here that we've noted what our function needs to, function. We've noted the input here. We've taken the first person, and we noted the output, what this function is intended to do. We print the first person drinking Coke. So let's go ahead and just try and code in accordance with what it is we commented. I've kind of like made this in beforehand, but here we've noted that we want to have 3 people we want to print, ready to be printed, and I've chosen Susie, who's a fictional character here, and me and Anthony. And
those could also be fictional people.
Yes,
if we want them to be.
You never know. There might be a second Rahul out there. Definitely. But that being said, we're in a good place to kind of fill out this skeleton that we've developed here in comments. So here we have a first function that kind of defines Susie drinking Coke. Here's a second function with me drinking Coke. And here's a function with Anthony drinking Coke. And one thing that we kind of didn't write was that we have to call each one of these functions individually. So
I see some issues with this code already, and I'm assuming that maybe some students are saying this too. You might remember from the class that we talk about a lot of big thing with functions is that they help you avoid repetition. But I'm seeing, and we're hoping some students see this as well, these 3 functions look really, really similar.
Right.
Yeah. Susie drinks Coke, Rahul drinks Coke, Anthony drinks Coke. What this is not doing is it's not abstracting the problem. It's making it very specific to a very specific type of problem. Does Susie drink Coke? Does Rahul drink Coke? Does Anthony drink Coke?
Right. So like Anthony's saying, we've kind of repeated exactly what it is that we're doing. So the thing that we went wrong after we kind of broke down this problem into comments is that we didn't really group together and identify what it is that is repeating in the task that we created. So we created this task that we got to show 3 people and we got to show them drinking, but we didn't kind of ask ourselves what does it mean for a person to drink Coke? What does it mean for a single instance of our problem? And in that way, we could have grouped together the 3 functionalities here. And what we could have done is just summarized these comments into one comment that I'm going to write underneath. And that is, takes as input a string, a person, and prints that person drinking Coke.
What's really key here, as I'm looking at Rahul's code here, is he's saying a person. He's not talking about the first person or the second person. For hint, your stage 2 project, you might want to be thinking about, all right, not how do I make the easy level work or the medium level, but how do I make a level work, any level work? Right. That's going to be really, really key to you succeeding at this project.
Right. So how do I print just a single person? Well, I do this with the belief that once I find a way to do this task for a single person, then it's just a matter of doing this thing X number of times. So so one way that we can kind of simplify this problem that we have here is that we're really just taking a person's name and just adding drinks Coke to it. So in a way, we've just kind of written out all of our code at first, and now we're trying to optimize for that. So say that we have like person drinks Coke, and instead of Susie, we just have drinks Coke, and we pass in a person. So in this way, we can pass in whatever we want for the input person and just have person drinks Coke. So one way that I've optimized
Do you
that.
want to change that so that we can actually print the person's name as well?
Oh yes, that's what I was just about to do.
Oh, cool.
Oops. So here we've kind of like in this function that I've now written out here on line 22 here, you'll see that we've taken a person and drinks Coke, and we print out person plus drinks Coke. Now I'm not gonna build this because it's a pretty simple problem, but I think that you can very obviously see how we've just really condensed these three functions into one by simply thinking about like a person versus the three people that we have to print out. So we can get rid of that. And we've just lost like maybe 18 lines of code, which is surprisingly the number of lines that it takes to not pass a submission. So you can see that just by this little exercise, we've been able to eliminate like a huge portion of repeated unnecessary code. And with that, you'll be able to kind of kill two birds with one stone by making a proper function and not having it so long that it doesn't pass our requirements. So, and you'll see that the functionality is essentially the same. We've just really just taken a person and drinks Coke. So you might be asking yourself, like, what does this have to do with our stage 2 project? And I think that we've kind of, we've really just honed down on the ideas that we want to kind of get you guys to instill within yourselves after like doing this programming problem. So after you finish the stage 2 problem, we're hoping that you're able to now abstract parts of a problem to make it easier to understand how we can code it. We want you to kind of realize that by doing this, you've avoided repeating yourself in the future, and you prevented the development of really long code from the very beginning. You've also like prevented yourselves from repeating your code unnecessarily by really kind of breaking down the problem from the very beginning, and you refine your comments as you kind of go through this process of eliminating extra code. Because you'll see that I took those 3 original comments that I had in hashtags here, and I just condensed it into one in the proper format that we expect, which I not only say what the input to the function is, I also say what the function does. So that in a nutshell is kind of what it is that you want to take from this particular example here. And in regards to what it is this is supposed to be analogous to in your programming problem, we want you to think about the concept of a level in the abstract sense.
Right. Don't focus in so much on how do I make my specific construction of a level work? How do I make my specific construction of the easy level work? If when you have completed this project and you've done it in a way that uses functions well, that uses functions that are generally short and avoiding repetition, what you'll find is actually that your code will work on any level constructed in the expected format. So if your code works such that blanks are defined as underscore underscore one underscore underscore and so on, it will work on any string that people construct in that fashion. I could give you a random fill in the blank quiz that I built, and it should work in your code as long as it's done right.
Right. So that's kind of like a source of a lot of problems that we have. And remember that in the skeleton code that you receive, that the sample that you're given is an example of a level.
We have a question here. long as you have your code with you.
I'm here.
Asking about lines 12, 13, and 14. So 12, 13, and 14, right. So Rahul, can you share your screen again and actually show how you would call these functions rather than... So these functions that Rahul has at 12, 13, and 14 are obviously no longer in our code. We no longer have a Susie drinks, Rahul drinks, or an Anthony drinks.
Great point.
So what we actually want to do is just drinks coffee on person one. Or sorry, drinks Coke on person one, drinks Coke on person two, drinks Coke on person three. Rahul, why don't you actually run this code just so we can see what happens here. So if we run it, we can see in the output, Susie drinks Coke, Rahul drinks Coke, Anthony drinks Coke. Again, all off of one function. We do have to call functions for each individual time we want to like identify does a single person drink Coke. That's a result of our construction of the function. Our function only knows if one single person drinks Coke. I suppose you could construct a function that could take in a list of people and tell us who among them drinks Coke. But that's a more complicated example. Maybe that's something for you to try at home.
Yeah, it might be something that you want to implement for your stage 2 project. But the idea here is to kind of just simplify your thinking when you're trying to approach this problem. And yeah, you, like Anthony said, we could probably have something like person 2 or person 3, and then kind of adjust the inputs here to person 1, P2, etc. But the idea here is to simply extract away what needs to be done so that we're working with something sufficient enough to pass like all the requirements that we have. So let's stop sharing this for a sec. And yeah, so those are things that we wanted you guys to kind of come out with. Like, think about a level in the abstract sense, not 3 levels. Identify what a function needs. What needs a function. Yeah, sorry. Identify what needs a function after you've kind of broken down the individual tasks that you have for this problem in comments.
Yeah, a really great tip that I tell a lot of students when you're writing a function, really a function's like going to perform some task for you, right? So when you're thinking about the big problem and you identify the smaller tasks within that, and you figure out, okay, I want a function that does this particular task within the project. Think about 2 things before you write any of the code. And those 2 things are, what should I expect the result of my function to be? That's going to be your output, what comes at the return value. And the second piece is, what information do I need to get there? What information am I given such that I can achieve that result? And those are your inputs or your parameters, what goes in the parentheses. Those are what's going to make things generalizable and abstracted, so that you're able to write your code such that it works on a abstract input rather than a specific one.
Yeah. So that being said, some last minute tips for some things that Anthony and I noticed. And they may or may not be things that you have to do. If it doesn't help your thinking, then you don't have to ignore it. But so you can ignore it. But so one of the things that I don't suggest you use is the exact Mad Libs code that you've kind of worked through in the work sessions. The idea of kind of taking the Mad Libs code design is what you want to retain from those exercises. And that design is the replacement of words within a longer string. That, again, like is the essence of this project. But you need to kind of find a way to do that without like using the while loop and extra stuff sorry, I shouldn't say like without using the while loop. I don't want to get you guys confused. Don't use the exact code that you used before, because that can really like add up in lines. And it not only that, it kind of like takes away from the problem at hand. you want like previous problems to inform the design of your new problems, but generally, like when you're approaching a programming problem, you want to break it down without any interference from like other things that you've learned. And that's really important because the problem that you're looking at may not have anything to do with like previous problems you've seen before. So make sure that you're first breaking down the problem and you have like those comments where you have exactly what you want to do, and then you can think about what it is you did in Mad Libs that might help you in this particular situation.
We have a question that popped up in the general chat
Sure.
about from Stefan. He's saying the feedback he's received on this project says that he shouldn't be using while loops to cycle through the 4 questions. So it's hard to say. I without seeing your code, and I'm not fully understanding your interpretation of the reviewer's feedback. But I'll try to answer that as best as possible. I would imagine, so part of the specification, right, is that the user can select a level. You might run into issues if you're having the user select a level and then using a while loop to go through that, because then might not really be selecting. Like, if your while loop is always starting from the easy question, yet I'm selecting medium, then that's a dissociation between what the user input is and what your code is doing. So again, really difficult question to address here without seeing the code, without seeing the reviewer feedback. Essentially, I think it's this issue sounds like it might be more specific to your code rather than to the concept of using while loops. There certainly is a place for while loops in this problem. In fact, it would be quite difficult to do it without any looping there. What I would suggest you to do, again, think about the tasks. So if there is a task which is select a level, maybe you want a function that manages all the code that goes into having the user select a level.
Sorry, I'm just answering Paul's question. I don't know if you guys had trouble seeing the lower left corner of the Sublime text, but it was just printing out the output, and I just posted that in the event chat if you're wondering about that. But exactly what Anthony's saying, it's really it's not about kind of you like not using a while loop here, not using like a while loop there. Also, it's really about kind of breaking down a problem. And I can't really stress this enough because it's fundamental to coding before, because I'm sure you guys either have a firm grasp of the concepts or can hop on a 101 and then get a firm grasp of like the programming concepts. But just problem solving in itself is a different animal. And we also want to kind of help you guys get a mindset for that, because that's important moving on when you see other sorts of problems that you might be faced with. But yeah, so we have time for a lot more questions. If you have, or any questions that you might have.
Yeah, so we'll stick around for a little while. The Q&A is open, the chat is open. Feel free to chat us, ask us questions. There'll also be a quick survey sent out on the chat asking about how you felt about this new service that we're testing out here. We're hoping it's an improvement over Google Hangouts, which we've been using previously. So the survey was just posted in the chat. Please take that if you have time. Feel free to use the Q&A to ask any questions you have. Rahul, do you have any last tips that you can think of while we're waiting for questions to come in? Actually, I guess one that we didn't talk about, there's a huge thing in lesson 2.7, Dave talks about this a little bit with the days between dates problem. And one of the things he breaks that down into several tasks, and he talks about, the functions that we should use for it and what goes into that. I'll finish up my thought here and then address the question. one of the things he mentions is that one of the tasks is identifying, is a year a leap year? And he mentions that that's actually a very easy problem to solve in the scope of the larger problem, but he actually saves that for the last thing that he does. And the reason why he does that is because evaluating whether a year is a leap year, while that problem in itself is a little easy, it complicates the larger problem that makes writing the rest of the code more difficult. To me, that's very analogous to the Stage 2 project and the idea of having the user pick a level. And one thing that I see a lot of students do is that's the first thing they do, is they write some code, they write some function that allows the user to select one of 3 levels. And honestly, that's probably one of the easier functions to write in this assignment. I don't recommend starting there for the same reason that Dave does not start with the leap year. It complicates the rest of your code because now all of a sudden you're thinking about 3 different levels, and you might start falling into that mistake that we talked about earlier, whereby you're thinking about my specific levels rather than a level. So I really recommend you create one example level to run your code on and get your code to work on that single level first in a generalizable way, in an abstract way. And then once you've done that, then you can start thinking, okay, so now how do I get my user to have 3 different levels available to them? You'll actually find that's very, very easy to do if it can work on a level. So a couple of questions here in the chat. Dion's asking, how much does the raw input part of the quiz affect the complexity of my code?
Oh, I answered that.
I mean, I'm just going to answer them out loud here for people who maybe aren't on Q&A. Mm-hmm. So yeah, that's, as Rahul said, it's a necessary part of the program. It's just one line of code. That's what's going to allow the user to respond. The syntax for raw input is simply you assign raw input to some variable, and in parentheses for raw input, you have a string. That string is what displays to the user, and then what they type next and hit enter gets saved to the variable, and then you can manage that how you see fit. Evaluate if the answer is correct, do whatever you need to do for the problem.
Sure. Take a look at Paul's question, which I like. He's asking, can you show us how to use comments to plan out your code? I'm having trouble figuring out what functions to make. I'm glad that you kind of made the analogy between comments and functions, because that's what we were trying to hope for with this webcast. But so to use comments to plan out the code, the way I generally do it, using comments to plan out the code, is that I use the task that I'm given to form the comments. Mm-hmm. And I hope you guys saw that when I kind of broke down the question that I gave myself, which is show a user 3 different people drinking Coke. I basically literally took the words from the task and put it in comments in certain places in order to kind of identify directly what it is I have to do. Because by taking the very question that I'm being asked, I can really just on its face answer the question right away. And after I've kind of written out code and written out comments and got a basic functionality down, then I can kind of go back and at least argue that, I literally took the problem that I was given and answered it.
Great place to start would be the project specification that tells you what you're supposed to do for this project. And that's going to lay out essentially the rules of the game, right? So it's going to say it has to display the question first, and it has to ask the user for input. Then it should evaluate. Those are maybe things that you want to think about making functions, and you might want to think, okay, so which of these are tasks that belong to that I might have to repeat and that should appear in a function in some way.
Yeah, I'm really glad you mentioned that, because I think that we give a lot of information that sometimes might seem convoluted in the sample code that we give you. So what I suggest is kind of just erasing parts of prompt that we give you and only leaving literal action items.
Literally break it down into steps, like step 1, step 2, step 3,
yeah,
and then go forth.
And they're literally in comments already. So right then and there, you already have like
Yeah.
your tasks.
Comments are a great way to store those. Like some people call it pseudocode. Essentially, it's like a step-by-step process and algorithm towards solving a problem, but not written in a computer programming language. Jennifer also has a question. So as far as asking the user to choose a level in our quiz, is it appropriate to use if-else statements for choosing the level? Yes. In fact, that's probably one of the best ways to do it. It kind of goes on programming style, but essentially, I guess two ways you could do this is one, you could do it at the global level, meaning not inside of any function, and just that code is run immediately upon when you run the file, or you could do it in a function itself. I personally am a proponent of thinking that code shouldn't be written at the global level, but that's going to be up to you and your personal preference and style to decide that. But really, I mean, you can think about it like this, right? Like, so you have some prompt saying, like, please select a level. You're going to get that user's response, and then you want to find out if they said easy, if they said medium, if they said hard, or if they said something else. If you start to like say problems like that out loud to yourself, they kind of give you hints about like what coding techniques you might find helpful here. Use these keywords. And it's like if is a keyword in Python because it has it means something. It's not like it's just some like weird word. It's always like if this condition, then do something else. That's English.
So I think that unless anyone has any more questions, we can kind of wrap this up right now. But it seems like you guys have been asking some great questions, and from the questions that you've been asking, I've seen that you have hopefully gained a better mindset of how to tackle not only this problem, but other problems that you might face, not only in this standard degree, but in the future of your programming career. So if that's the last question, I think that we can kind of end this webcast.
Yeah, sounds good to me.
Awesome.
Thanks for tuning in today. Fill out the survey. Good luck with stage 2. We're here to help you if you need more help.
And eat your vegetables.
And eat your vegetables.
See you guys.
All right. See ya.